Hello, everyone. Welcome once again into our channel, Making Life Easier. Kindly subscribe to our channel, like, comment, and hit the notification bell as well. Once again, we are continuing with our series on basic mechanics, and we are looking at the resultant of forces in 3D, example 2. Quickly, let's look at our question. Two cables are used to hold a rectangular block at a fixed position at A. If the tension in the cable AM is 540 newtons and the tension in cable AQ is 620 newtons, determine A, the magnitude of the resultant of the forces exerted at A, B, the direction of the resultant forces exerted at A. So let's look at how to solve this question. Good. We have seen that this question is a 3D question. We have the x-axis, we have the z-axis, and then we have the y-axis. And then we have two forces, A, K, and then AM. And we are told to find the force exerted at A and the resultant of the forces exerted at A. So we have two forces. Don't forget that here our focus is on point A. And because our focus is on point A, these are cables. So the tension force will point away from our cable. Our focus is A. The question says that we should determine the resultant of the forces at point A. And when you are resolving forces for tension, they always point away from the point of interest. So our forces will point away from our point A. This will also point away from point A. Don't forget that. Once you have been able to establish that, don't also forget that our unit vectors are always in this direction. The J is always, when it is moving up, it's positive. When our X is moving this direction, it's positive. And then when our Z is going this direction, it's also positive. But if it is in the opposite direction, then it's going to be negative. So this will be negative A. Opposite direction, this way will be negative I. Opposite direction, this way will be negative J. Don't also forget this. We are going to apply it in solving our problem. Good. So having reached this point, now we have two forces, which is A, M, and then we have A, L. So let's represent AM with F1, and then represent AQ with F2, so that it will make our analysis easier for us. So now, we are asked to determine the resultant force, and we know that the resultant force will be the vector force of F1 plus the vector form of F2. So it means that our first point of solving this problem is to determine this F1 in the vector form and F2 in the vector form. What we were given in the question was the scalar form for F1 and the scalar form for F2. So now, let us determine the vector form for F1. For F1, we know that our F1 will be equal to F1 lambda. So let's determine our lambda. And we said that our lambda will be equal to distance in the x-axis plus distance in the y-axis. Here we have not been given any angles which the force make. We have just been given the distances on the object. So it means that we are going to get the lambda using distances. Take note of that. We don't have any angle there. We don't know the angle the forces makes with each of the axes. We have just been given the distances. So it means that we are going to calculate our lambda with the given distances. So our lambda will be the xi plus the yj plus the zk all over d. Good. We have already used these formulas in our previous examples. So it means that for F1, our lambda, we are going to move our F1. Don't forget that we said that it's representing AM vector AM. It means that from here, don't forget that we said that our force is from A, the point of action is A to M. Our force is from A to M. So if you want to obtain our lambda, which is the directional cosine for A to M, it means that we need to move around the object till we get to M. And in that case, it means that we are going to move this distance here. Look at the direction. Look at the direction. It's in the direction of what? It's in the x-axis. The direction is in the x-axis. But look at this. Are we following the direction of our unit vectors? We said that anytime we are moving this direction, if it is in the same direction with our unit vector I, then it's going to be positive. So we are moving from this point to that point. So in that case, it means that the distance will be 1.5 plus 4.5, and that will be 6. That will be 6. So it means that when we are moving from point A to M, we first move from this point to that point, and we are saying that that is the distance on the x, and that direction is in the same direction with our unit vector for x-axis. So it means that it's going to be positive. So we are going to get positive 6i plus. Then from this point, we are going to move down. We are moving down on the y. And we are saying that anytime we move down on y, we are going to get negative j. So the distance there is 2 meters. It means that we are going to get negative 2 meter j. Negative 2 meter j. Negative 2 meter j. And then from there, we are also going to move this distance on the z. This distance on the z. Look at the direction. It is in line with our unit vector k. So it means that our direction for z is also going to be positive, and the distance is 3. We are going to get plus 3 meter k. Then from there, we can find the magnitude of Km. So the magnitude of Km is going to be the square root of 6 squared plus negative 2 squared plus 3 squared. And from there, our magnitude of Km will be equal to magnitude of Am will be equal to 7. So from there, our lambda will be equal to 6 meter I minus 2 meter G plus 3 meter K all over 7. And from here, we can get our lambda as 0.85 I minus 0.286 J plus 0.426 K. Then once we have been able to obtain our lambda, then we can be able to get our force, because we know that our force in the vector form is equal to F lambda. We have been given F in the question that Fm is 540. So it means that our force in the vector form will be equal to 540 into bracket 0.857 I minus 0.286 J plus 0.426 K. And from here, our F1, which represents Am, will be equal to 462.78 I minus 154.4 G plus 230 K. So we have gotten for F1. Now we are left with finding for AQ. In the same way, AQ is pointing away from the point A. So we are moving from this point to that point Q. We are moving from point A to point Q. So you can see that, so for F2, which you are saying that is equivalent to AQ, we need to get our force F2, which is equal to F lambda. So in that case, we are not giving the angles, but we have been giving the distances. So we can get our lambda from the distances. So we can say that AQ vector AQ will be equal to, sorry, that is not the magnitude. That should be rather the vector. That should be the vector AQ. So our vector AQ will be equal to, you can see if you want to move from A to Q, We move from this point to this point like this, but look at the direction. It is in line with our unit vector for I. We are moving in the same direction with our I. They said that if you are moving this direction, it's going to be positive. So our distance on the x is going to be positive to this point because you are moving to kill. So to this point is 1.5 I, meter I, plus. Then from here, we move down here on the y. We are moving down. We are moving down. So it's going to be negative. But anytime you are moving down on y, you say that it's going to be negative. So you are going to get minus 2 meter j. And then from there, we move on the z, this distance. Look at the distance. It is in the direction with our z. It is in the same direction with our positive z. So our distance is also going to be on the z is going to be positive, and that will give us 1.7 meter k. Once you have been able to establish that, you can get the magnitude of Kyekyere. Magnitude of Kyekyere will be equal to the square root of 1.5 square plus negative 2 square plus 1.7 square. And from here, our Kyekyere will be equal to 3. And from there, we can get our lambda as all what is here over 3, which will be 1.5 I minus 2j plus 1.7 k all over 3. And our lambda will be equal to 0.5 I minus 0.67 j plus 0.57 k. And once you have gotten that, we should be able to get our F2. Our F2 bar will be equal to F2 lambda. And we have been given F2 from our question. We have been given F2 from our question. So we should be able to find F2 in the vector form. We should be able to find our F2 in the vector form. We should be able to find our F2 in the vector form. So now, if we want to get our F2 in the vector form, then we just multiply our direction cosine by. So we can say that our F2 in the vector form will be equal to F lambda, F2 lambda. And our F2 from the question is given as 620. So we can say that 620 into bracket our lambda, which is 0.5 I minus 0.67 J plus 0.57 K. Then once you have been able to get this, we can be able to multiply through, and we get 310 I minus 415.4 G plus 353.4 K. Then from here we can see that our F will be equal to F1 plus F2. F1 plus F2. And from there, we have gotten our F1 already, we have gotten our F2 all in a vector form. So we can put them together to find our resultant force. And then we can see that our resultant force will be equal to 462.78 I minus 154.4 G, which is for F1, and the K component is 230, plus our F2, which is 310 I minus 415.4 G plus 353.4 K. So from there, we put all the I components together, we put all the J components together, and we put all the K components also together to get our resultant force. So from here, we can see that our resultant force, when we put all the I, so this is I, this is I, this is I, this is J, this is J, this is K, this is K. When we add this and that, it will give us the H component add this and that to give us the y component, this and that to give us the k component. So from here, our f, which is our resultant in the vector form, will be 772.8i. That is when you add this and that, minus 569.8g, which is if you add this and that, plus 583.4, which also means when you add this and that. So from here, we have been able to get our resultant force in the vector form. But the question was telling us to get the magnitude. So the magnitude of our F will be equal to the square root of whatever is here. So 772.8 squared plus negative 569.8 squared plus the last one square, which is 583.4 squared. Then from there, the magnitude of our force will be 583.4 newtons. Then once we are done with that, the next part of the question, so this is our A part of the question, find the resultant of the force. Find the magnitude. The first question was to find the magnitude of our resultant force, and the second one is to find our angles. So from our angles, we can say that we said that cos theta xi is equal to the force in the x-axis, which is this force, over the magnitude of the forces, which is F here. And then that should be able to give us 772.8 over 583.4. 83.4. And then from here, we can be able to get theta xi, and theta xi from there. When you find the cos inverse of whatever is here, we are going to get 46. We are going to get 46.5 degrees. And we can also find the angle for all the others. So the angle for our y, the angle the resultant force makes with the y-axis. So what we have already found is the angle the force makes with the x-axis. So the angle the force makes with the y-axis, cos theta y, will be equal to f of y over f, and that will give us negative what is here, which is y-axis, over our resultant, which is negative 569.8 over 583.4. And if you find the cos inverse of whatever is here, our theta y will be equal to 120.5 degrees. We can also do that for our z-axis and say that cos theta zk will be equal to f of z over f. And f of z is our force here, 583.4. So we are going to get 583.4 over our magnitude, over the magnitude of our resultant force, the magnitude of our, I think the magnitude of our resultant force from here should not be 583. It should rather be 1123.5 newtons. Sorry for that. So this one will not be 583, but it will be 1123.4. 1123.4. And it should give us this same angle here. And this one should not also be 583.3, but it should rather be 1, the resultant of the forces. So it should be 1, 1, 2, 3. It should be 1, 1. Sorry for that. It will be 1, 1, 1, 1, 2, 3.5. And here our F magnitude of F will also be 1123.5. And then when you do that computation, our theta zk should be able to give us 58.7 degrees. And that is pretty simple. We have get our resultant force and angle the resultant force with the x, with the z-axis, with the y-axis, and with the x-axis. Once again, thank you very much for watching. If you have any comments, if you have any suggestions, if you have anything which you don't understand, you can kindly share with us at the comment section. So once again, don't forget to subscribe to our channel, like and share as well, and then also leave all your comments at the comments section. So we are done with solving our problem on this. Thank you for watching. See you in our next video. Bye-bye.